Okay, good morning, year 11, year 12. As promised, I'm going to discuss or just to talk to you and show you what we mean when we want to list the features and the domain and range of a graph, okay? Any graph, so not just these exponentials. Well, that first graph, graph I, came out to be that formula there, y equals 4 to the power of x plus 2 plus 2. Now, if you want to talk about the domain of the graph, what you're really doing is you're saying, for what values of x is this graph valid? Or let's put it a different way. For what values of x can this graph be drawn? Well, it doesn't matter that we can't see the top of this exponential graph. This exponential graph goes on and on and on. And that means that you can find a value for y for any value of x there. And so what you're really saying is that this function, this exponential graph exists for all values of x. And that's what we call the domain of the graph. So what we say, the domain of the graph is all values of x. Another way of writing it is minus infinity, which is that way, and plus infinity, which is that way. We write it like that as an inequality because x must be somewhere between that and that. Okay, just bear in mind that this minus infinity and this plus infinity, they are not numbers. Infinity is not a number, it's a concept. It's a concept of never-ending numbers, okay? So mathematicians don't much usually like writing things like that, but I think it's pretty clear what we are meaning. Now, as for the range, what we're looking at here, we're asking the same questions, but this time for the y values. In other words, we're saying, well, for what y values is this function, this graph, valid? In other words, for what y values does this function exist? Well, it only starts above the asymptote. Okay, the graph can never come below this dotted asymptote line here. So it only exists for y values which are above 2. And that's what we write it like that. Okay, only valid for values greater than 2, not greater than or equal to 2. It never touches that asymptote, so it never equals 2. Y never equals 2, can never equal 2. So you can say y must be greater than 2. Okay, now fairly easy concept really. Now the features, first thing you've got to say, you've got to name what the graph is. You wouldn't call it a parabola. You wouldn't call it a straight line. You wouldn't call it something else. You would name it, give it its proper name. It's an exponential curve. Furthermore, it is a positive exponential curve. Positive because as x becomes positive, so y becomes positive, increasingly so. Okay, and the third thing, which is extremely important, is to mention the equation of the asymptote. It's no good just saying there is an asymptote. You have to give the equation of that asymptote. Okay, y equals 2 is the asymptote. That's a feature. All right, let's look at the next graph, the graph I. There it is there. And we got that equation there, y equals 3 to the power x minus 2. And if we look at it, it was doing something like this. There's an asymptote at y equals minus 2, and it was going up like that. Well, as you can see, the domain must be, again, all the values along the x-axis. So again, we can say that minus infinity is less than x, which is less than infinity. And the range, this time, the range must be for any y value greater than minus 2. There it is along there. In other words, this curve, which cannot go below this asymptote of y equals minus 2, does not exist for negative values of y. So it only exists for values of y which are above this -2. So we say y is greater, for the range, y has to be greater than -2. Now the features, well, again, it's a positive exponential because as y is getting more positive, so, as x is getting more positive, so y is getting more positive. And it has its asymptote at y equals -2. Okay, next one. This one here. Again, I've drawn it in again, and you can see that the domain is going to be the entire values on the x-axis, and the range this time, y has to be greater than 3. Okay, the curve cannot cross this asymptote line, so it does not exist for values below 3, in y values below 3. So it only exists for y values which are greater than 3, and that's what we call the range. The features, again, it's a positive exponential, and there's an asymptote at y equals 3. Okay, and you mustn't forget that if you want full marks after you've found the equations of these exponentials, or any graph really, you need to state what you think the domain is, state what you think the range is, and you must mention the features of the graph. Are there any asymptotes? Is it a positive hyperbola, or a positive exponential, or a negative parabola, or whatever? They are very important things to mention if you want full marks. Okay, let's look at the last one. The last one, remember, there was an asymptote at y equals 1, and it's doing something like this. And this one you would describe as a negative exponential, and you would then say that the domain is all the values along the x-axis. The range this time, that y has to be, you have to be careful here, because y this time has to be less than 1, okay? Because the graph exists for all the y values in this direction. It does not exist for y values greater than 1 or equal to 1, okay? So it's important you get that inequality statement the right way round. Okay, features negative exponential, asymptote at y equals 1. And what I've done at the very bottom here is I've tried to just explain in very simple words what the domain and range are. Well, the domain shows all the values of x for which the function exists. The range shows all the values of y for which the function exists. So don't forget to make sure you understand the difference between a domain and a range. Okay, right, I hope that helps, and there'll be some more work coming your way for page 15 and 16. Page 15 and 16 are mixed graphs. So I want you to have a go at all the questions on these 2 pages. You are now should be equipped to have a good crack at these, okay? This is a very important thing, because when we get onto mixed graphs on page 17, you'll see that they're all mixed up and joined together. That is where we're heading. This is where we've got to get you, okay, for this course. All right. Hope you're keeping safe, and I'll hopefully one day see you soon. Bye.